Okay, audible? Hello, am
Yes,
I audible? Am I audible?
Yes, sir.
Okay. Okay, fine. So now we are moving towards the unit number last, that is number 6. Okay. So first of all, okay, please check whether my screen is visible or not. Then we'll move forward. Is it visible?
Yes, sir.
Okay. So, unit number 6, that is design, planning, and layout of high voltage laboratories. Okay, so whatever we had learned in a first, second, third, fourth, and fifth unit, that all combinational part will comes under the unit number 6, that is design and planning and layout for the high voltage laboratory. Okay, so in this case, the important thing is that how we are going to plan, how we are going to design the layout of high voltage laboratory. So mostly these high voltage laboratory, we design at institute level or engineering college, or we can say at any commercial areas or industrial areas where it is necessary. Okay, so what parts, what factors that are matters regarding the designing as well as planning for the layout of high voltage laboratory means, which things we have to consider, then what are the various types of the high voltage laboratories, which kind of equipment should be there in the laboratories, that all things we will understand one by one in this unit. So first of all, we'll before going for the aim of this chapter, so we'll just introduce with the syllabus. As I told you that we will identify what are the, or what should be the test facilities that should be provided in a high voltage laboratories. Then second one, that what kind of activities and what kind of study that we will conduct or we will connect in a high voltage laboratory. So again, as told, there is again classification of the high voltage laboratories we have to discuss before the designing as well as planning. Then size and ratings of the high voltage laboratory means what means, whenever we are designing as well as planning the high voltage laboratories, we need to think about the size, means what kind of the instruments, what kind of the electrical apparatus we can test in our high voltage laboratory. That is also important part, and we have to think about that one. The last point is that grounding of impulse testing laboratories. That is very important, as I discussed earlier in last lecture, last 16 15 minutes, that every electrical high voltage rating electrical equipment should be grounded properly, right? So due to that grounding, whatever be the damages, or we can say whatever be the surge current, or due to the lightning strokes as well as surge strikes, that whatever current is inducing, that means that impulse current for the stiffness, for example, this is a highest current for the particular time moment that will goes to the ground, where you will that will get the low impedance path. So again, we'll discuss about the objective for this unit. So first thing that will introduce to various factors for the electrical power systems. So what kind of the parameters, or what kind of the various factors that we will think, what that we will understand. Then to make student understand the classification of the high voltage laboratory, means there as per the sizing, small scale, a medium size, a largest size, as per their sizings there will be the classification for the high voltage laboratories, so that we will understand. Then again, understand the sizing and rating of the high voltage laboratories, means what kind of apparatus, what kind of electrical equipments that we can test, what should be their sizing, what should be their ratings of we can implement into the high voltage laboratories for the testing purposes, that we will understand. Then what will be the outcomes for these units? Once we will understand this unit, then we will be able to will be able to understand whatever be the outcomes of these, like we can say we can understand, as earlier told, that various factors. Then we'll understand the procedure of the sizing and rating of the high voltage laboratory, as well as we can understand the various tools and the devices that are being used for this high voltage laboratory. Okay, so now without wasting a time, we'll switch over to our major point, that is the uh, a design platform, or we can say the design parameters that we will discuss here, right? So first thing that we should understand, that is about the high voltage laboratory, that whenever we will think about the industrial development, or we can say there is a point which is connected, that is economic development. So in such scenario, or we can say in current world demands, as we know that there is more and more electrical energy is required, and we have to transport this energy over the long distances. Means suppose, as we know that the electricity is generated as one of the time, here we can say the Parali, which is located in the district of Maharashtra, that is Bid. So from Bid, we have to transport that electricity towards the Pandharpur, towards the Solapur, towards the Karad, Vita. So that is again in a large quantity. So whenever we are transporting that such amount of electricity, or we can say this power, so to avoid such kind of losses, we need to use extra high voltage. That means HVDC or HVAC transmission lines. That means high voltage AC or high voltage DC transmission lines. So in everywhere in the world, whatever be the transmission lines that are carrying around 760 kV, and we can say in again in our India also, I think there is a 11765 kV transmission line is there. Also whenever the transmission lines will having the ratings of 1000 kV as well as more, so in a USA, in USSR, there are 1000 kV as well as 765 kV lines. Okay, so means whatever be the studies that is we are conducting for the different countries, that is only possible whenever we will transport the high voltage, or we can say the DC systems for the plus or minus 400 kV and above the same rating. So whenever there is a point of the fastest development or the growing country, that time we should follow whatever be the studies for the equipments, as well as whatever be the service conditions are there, so that all service conditions and requirements that should be satisfied, that should be fulfilled. So all these conditions are as per the specific standard specifications, we can say, and these will determine whatever be the values for the power frequency, whatever be the value for the DC transmission line. So all that things all under specific conditions. So like how much impulse current that should allow. So all that things we will discuss. So in India, as current state, we can say whatever be the transmission voltage that is reached around 400 kV. So that is again few electricity boards are adapting the voltage for their long distances or long voltage transportation system. So in India, we can say this is around, yes, this is around a long distance calculation, and we can say it can be around 400 kV. So for the national grid, at a transmission voltage level, we can expect that around the 400 kV or even higher than that 400 kV. So all should just keep a note that in India there is a 400 kV or even more higher than this is expected. So as per these expectations, we can say whatever be the electricity that needs to be transferred, that should have a high voltage or high magnitude. So in another coming next 10 years, we can say that whatever be the 4K, 400 kV lines, that should be uh, uh, come to the end around 10,000 kilometers. So that will be the length for the another next 10 years. So whatever be the high voltage laboratories that is having a, as we had told that this should be fulfill all the necessity conditions and all that thing. So here that conditions means that has to pass all the test. So what are the tests? As we already discussed, whatever be the test for the surge diverter, test for the circuit breaker, test for the insulator, test for the transformer. So all that test has to be passed by the all electrical apparatus, and then and only then we can say that extra high voltage transmission system become comfortable, become successful to carry the 400 kV supply. So in such cases, we can say whenever the work is in under progress, work is under development, at that time we should understand whatever be the research has been conducted by the researchers, as well as they have planned to ensure economical as well as reliable as well as flexible extra high voltage transmission system. So in such scenario, we have to take or we have to conduct all the tests for the electrical apparatus, and whenever the test will passes, then we can see there is a perfect successful extra high voltage transmission system is present. So let us go for the activities and studies which are available in a high voltage laboratory. So first thing that we have to understand, in a high voltage laboratory, it is expected that we should carry the conduct or we should conduct the withstand or a flash out test at a high voltages. So some if transmission system equipments that we I have kept note here, that the first important equipment for the transmission line, that is a transformer. So as everyone know that transformer is used, as suppose this is a generating station. Okay, this is a generating station, so it is generating around 11 kV. So if we are talking about to transport around a 400 kV, then what need to do? Then it has to connect with the transformer. So this transformer will convert that 11 kV to the 400 kV. So that means it is a step up transformers. Then it comes to our district level substation, and here it needs to again step down to 400 kV to 132 kV. Then when it comes to near our tehsil, or it nears to our home, that time it again 132 need to convert into 11 kV. And again that 11 kV will be converted into 440 volt, and then this will gives to domestic use, or we can say agricultural purpose, three phase 450 volt, 440 volt that is to be given. So this is the simple transformer, which is the equipment used for the transmission system. Then again another one, that is a lightning arrestor. So what does means lightning arresters? So lightning arresters, I'll just explain shortly. So as we know that whatever be the lightning arresters we are talking about, that important parameter for that, if you see there is a substation, and at that substation at this end there is a one tower, and this is known as a lightning arrestor. So there is even a board, and on this board you can understand how much times there is a lightning stroke occurred. So if suppose there is a lightning like that way, if suppose there is a lightning of several times, then it will measure how much voltage that has been generated, how much current was withdrawn to the earth, or it has grounded. So all that things that lightning arrestor will keep in mind. And important thing is for the lightning arrestor is that it will grant the excessive current or excessive high voltage. Okay, so this is again another protected device we can say used in a power substation or power system. systems. Okay, so another thing that we should understood, that is again, if suppose we are talking about the power system of the transmission line, then isolators and circuit breakers are again important role playing. So what does it mean, isolators, what does it do, and what is another functions, or what is the use of isolator, how these will perform, how these circuit breakers will work. So all that things we should understand properly. As before that, I like to tell you that whenever we will think about the isolator, so what does it mean, isolator? Isolator means it is a different, or it is a separating two conductors, or it is a separating a two electrical contactors. Means suppose this is a substation, and if suppose there is a feeder 1, feeder 2, feeder 3, and feeder 4. So that feeder means suppose this is for the X village, this is for the Y village, Z village, and this is for A village. Then the isolator, suppose there is my power transformers. Okay, so from these power transformers, whenever my supply is coming to this level, there will be a circuit breaker. Okay, or there is a circuit breaker. So there are circuit breakers, and after that there is a isolator. There is a isolator. So why these isolators are there? So these are the manual, or as well as we can say these are the automatic. So in these such cases, we can consider that these isolators are here to only the separate two electrical parameters or two electrical contactors. Then what does it means by circuit breakers? Circuit breakers are used here to control the electrical, or to protect the electrical apparatus from very high damages or hazards. Suppose there is some short circuit, there is over voltage, there is overloading. At that time, my circuit breaker will get sensed, and that will not allow excessive current as per the determined specifications. So that isolator and circuit breakers again playing an important role in a transmission system. That is why it is used in a power system. So another, that is different types of the insulators. So now again we know that pin type, then tackle type. So all these suspension type, in pin bar. So all these type of insulators are used. So why these are used? Because as we know that around the transmission line there is a, after every 150 meters there is a poles, there is a towers, and that every towers is belongs to the insulators, and that insulators are used to reduce the tension of the line, as well as to give the protection, as well a protection for the grounding through this tower. So there are again different types of insulators that has been a part of a power system, or we can say that part of a transmission system. Then cables again, in case of the underground transmission system, there are huge use of the cables which are already insulated with the very various insulating materials. So you all should understood that cables and then capacitors are used to, we can say, to feed up the extra voltage if it is necessary. So that is used for the backup purposes also. So line hardware and accessories. So what are the line hardwares and accessories? Like that T, as already seen, or we have seen that there is a tower and there is a T wire. So this means that this is the line hardware, or we can say this is accessories. So other equipments like reactors, filters, so these are used for the limiters. So all these equipments are part of a transmission system, and has to be done a what we can say, whatever be the testing is there, that has to be done by these all the equipments, right? So a more important and another thing that is about the we can say, so the important test that has to be carried out on the equipments are again power frequency withstand test, weight and dry. So already we have discussed that test. So there is a high power frequency which has been used, and in that frequency we will check that several applications, several samples we will taken out for the weight as well as dry conditions. And in that conditions, that above all equipments we will check whether it is going to passing the test or not. Then impulse test, so very high impulsive for around 4 by 10 microseconds. For that time period, very high voltage we will input on these equipments, and we'll check whether it is whether it is passing or not. Then DC withstand test, switching surge test under polluted atmospheric conditions. Then all these means in such cases we can say that whatever be the partial discharge and RIV measurement, that is radio interference voltages, that already uh, as I told you in extra lecture, that RIV is playing a very important role. And in such cases we should understand whatever be the partial discharges are there. So everything we have to think about in a proper way. So then and only then we can say that all the test has been passed by the equipments which are used in the power or transmission system, right? Then what will be the next? That is the test facilities provided in a high voltage laboratory. So now, what will be the test facilities? Means which kind of test we can carry out for these in this high voltage laboratory, that we will understand. So high voltage laboratories in such conditions, we can say whenever we are carrying out the test on a various equipments, at that time we, if suppose we are doing any research, we are doing any development work on the equipments, at that time first of all we have to think about the safety factors. So whatever be the safety factors are there, that factors should be related to the reliability, related to the flexibility, reliability, related to the dielectrics test, as well as related to the atmospheric conditions, such like there is a raining, there is a fog, there is a wet condition, there is industrial pollution. Such kind of things we need to consider before the testing. So at voltage higher than the test voltage is again required. Means if suppose we are taking a test of a 10 kilovolt, then my normal voltage should be at least greater than the 10 kilovolt, so I can conduct the test voltage, or I can take the test voltage. So sometimes what happens, whenever we are doing a research, whenever we are solving a problem, at that time that all other equipments which are coming under the normal atmospheric or pollution conditioners, that cannot be response properly, and that time it may be possibility that whatever be the equipments or apparatus we are using, that may fail. Okay, so here what are the research activities that we are including these such test facilities as well as everything? So there is a first thing, that is breakdown phenomena. What does it mean? It is a breakdown phenomena in insulating media such as gases, liquids, solids, or a composite system. Means first thing, in a second unit, we had seen that breakdown phenomena in a solid. Then third unit, we had seen that a breakdown phenomena in a liquid as well as gases. So that breakdown phenomena means what? At a particular moment, if the voltage, whatever happening, that is getting breakdown. So due to that breakdown voltage, that insulating media gives such kind of leakage current, or some voltage may drop out. Due to that, this breakdown phenomena is most important activity which need to do in a laboratory. Then second thing, that is the withstand voltage on the long gaps. Surface flashover studies on equipment with special reference to the equipment and the material used in a power system. So important thing, what kind of material that we are using. So whether it is ISI certified, whether it is ISO mark, then whether it has passed the quality assurance test. So all that things we need to take consideration. And whatever be the withstand voltage, suppose there is a gap, suppose we are increasing that gap, and that moment we will just check whether it is withstanding or not. Then surface flashover means what? As due to the corona, there may be a radio interferences, and due to that, what kind of flashovers means means wet flashover, means dye flashover. That studies we need to consider for the specific equipments under the specific materials that has been used in a power system. Then as I told you that electrical interference studies. So what does it mean? Electrical interference studies means, as we know that the telecoms lines, that radio lines, TV, television lines, that are passing around these transmission lines. So that having again radio frequency, that having a radio interference. So due to that, whatever be the equipments that we are using, there may be a possibility of the discharge. So discharge from these um, equipment are operating at high voltages. So that is again important parameter. Then studies on insulation coordinations on a high voltage power system. So studies on a insulation coordination means what? Means whenever we are thinking about the insulation coordination, means what? There is a class A to class F type of insulations, and then high voltage power system lab, we have to make coordination of the all the types of insulators. Means in a cables there is a sheathing, there is armoring, there is a covering. So in that cases we need to take consideration of this coordination. Then last research activity that we have to take a chance, that is a high current phenomena, like electric arcs, like a plasma physics. So like that way, we have to consider whenever there is a high electricity or high current is passing, that time high current phenomena, such kind of electric arcs and the plasma physics we need to think about. So these are the 5 research activities usually we conduct in a high voltage laboratory. And other than this, there is a another planning as well as layout that will takes a very much costlier thing. So whatever be the testing equipments we are choosing, the investment is around a maximum, but whatever be the utilization of this equipment throughout the high voltage laboratory should be again maximum. So this is all about the test facilities provided in our high voltage laboratories. Okay, so in this, if any doubt, please let me know, so we will conclude, we will um, discuss on that, and then we'll move further. Is there any doubt? Yes, is there any doubt? If no, you can simply say there is no doubt. If you have any doubt, you can ask. Any doubt? Am I audible? Am I audible?
Yes, sir.
Okay, so voice is not a problem. That you are not responding, that is the problem. Okay, no issue. Fine. So now we'll move towards the next point, that is about the classification of a high voltage laboratory. So now laboratories. So as we know that there are various purposes behind the product, behind the designing of high voltage laboratories. So what kind of laboratory design purposes are there? So the purposes are, first thing, that is a major intention why we are doing this laboratory. Second intention, that how much amount we are spending on this laboratory. So again, based on this, if suppose finance is less, then we so so based on these parameters, like what kind of intention is there, what kind of resources are available, how much finance or how much amount we are spending on that. So based on this, we will design, or we can classify the laboratories in a 3 parts, that is a small laboratories, medium sized laboratories, and large general laboratories. So in such laboratories, suppose we are thinking about a small laboratory. So what kind of a small laboratory will be? So it is a small laboratory, means as its name suggests that in size it is a small. How much voltage we can, or how much amount, or how much ratings or sizing of this laboratory will be takes place. So this will discuss. So here the whatever be the power frequency test equipments are there, so their rating should not be should be less than the 10 kilowatt, or we can say 10 kVA rating, as well as whatever the impulse equipment of energy rating, that should be a 10 kilojoule or below that. Also whatever be the voltage can be, or voltage rating, that should be about 300 kV for the AC, or of suppose 500 to 600 kV for the cascaded unit. If suppose single unit is there, then 300 kV is enough, but for the cascaded unit, 500 to 600 kV for the that purpose. Then plus minus 200 to plus minus 400 kV for the DC, and the less than 100 kV will be the impulse voltages. So such kind of things we can normally equip into the room. Whatever be the room or hall size will be around 15 meter by 10 meter by 8 meter, means like that way. This should be the 15 meter, this should be the 8 meter, and this should be the 10 meter. So like that way, whatever be the room size will be there, that will we will think about. So this is all about the small laboratory. So whatever be the sizing, that is 15 by 10 by 8 meter. Okay, so this is your width, this is your height, this is your length. So like that way you can understand how much this laboratory is having consuming the space. Then whenever whatever be the requirement of these or we can say whatever be the ratings of this equipment, such kind of they are limited, so they can accommodate into the rooms like which having height of around 5 meter to 6 meters. So in such cases, that is preferable that we will just develop these lab, this kind of labs into the engineering college or university associate with the local industry or R&D organization. So at that time, it is very important that what are the parties are concerning about this, that should be very responsibly having responsibilities, or they should decide to define how these test facilities and the time for the test facilities how to as to be shared. So another one idea regarding the small laboratory is that is have to that whatever be the university has to be there, that has to decide the whatever be the syllabus for the this high voltage laboratory through open this facility due to the through the regular technical training programs, as well as there should be a high voltage training by the conducted by the clients. Okay, so there may be a high voltage problems which can be solved with the help of these moderate voltage levels, and such kind of laboratories should be built with the amount of 2 to 10 million rupees. So this amount is around as per the 1991. Okay, so in current scenario it may be around 10, 15 millions to 20 millions, means that much amount is required for this laboratory investment or to build up or to develop the laboratory. Okay, so just to keep in mind that amount is not very small, it is very high, and in through this amount you should just develop the laboratory. Okay, so as we have discussing very important factors, very important parts of these electrical high voltage laboratory. So I request you all to, if you have any questions, please raise a query. If you don't have any questions, then we'll go further. Okay, so another point that will go for this is a medium sized laboratory. So again, we'll think about the medium sized laboratory. So what kind of laboratory is that? So medium size means it is an industrial laboratory. So in such kind of laboratories, we understood the what is the function or what is the major function, or we can say major intention behind that. That is the doing routine test. Means suppose in an industry, if suppose there is a transformer repairing company, so whenever they will repair the transformer, they have to go, they have to transport the transformer for the testing purposes. So that demand for the future test as well as the resources that has to be extended very future concern. So due to that, whatever the production targets and there, and for that purpose, that laboratory has been planned and designed as per the medium size. So what are the plannings or that should be included into that? So first, that is the ground support. Ground transport means, and ground support means at whatever be the, suppose I am installing in a one medium sized laboratory at a Pandarpur, then I should get whatever be the local level manufacturer or maintenance workers, they are there, they may use that laboratory. So if there is a transport facility, means if suppose the railway tracks are near to your laboratory, then it is again very easier thing that some of the people which can be take that all these laboratory tools the transportation purpose. Then handling equipments like a crane. So whatever be the handling equipments means, in case of the crane, as there are multiple motors and whatever be the things that are used in a crane, so that we will understand in a cranes. Again, the rationalization of test procedures. Rationalization means what? Means whatever be the instruments are there that has to be accessible, and due to their accessibility, we can say whatever be the things are we are considering that for the easily access. So means, and again the providing pro rooms for the possibility of increasing voltage rating. If suppose there is a voltage rating increasing, at that time this medium sized laboratory will take a routine test properly. And in such kind of laboratories, whatever be the power frequency testing facility, that should be in range of 200 to 600 kilovolt. And again, that is also depending on the rating as well as size of the equipment that has to be manufactured and that has to be proposed for the testing purpose. So in such cases, what kind of electrical equipments that are used in industrial sectors, that is again cables, transformers, and also whatever be the ratings are there, it will be around 100 to 1000 kVA. So in such cases, whatever be the impulse voltage generator that should be required, that is again having a rating of 20 to 100 kJ, means kilojoules or more than this. So whatever be the other equipments like a impulse current generator for the testing, at that time that surge diverters as well as the DC test facilities, and whatever be the transformers, cables, capacitors, that are also made available. So with the help of that, in a industrial laboratory or a medium sized laboratory, we can take benefit of testing or doing a routine test of each and every equipment that has been used in a power system. So in such cases, in such kind of industrial laboratories, whatever be the research work as well as the development is doing, is should be the having the flexibility, and that should be available for the in corporation companies, or we can say whatever be the in component of new equipments or new apparatus that has to be done routine test through these medium sized laboratories. So we can say it is very important part of these industries. As point of electrical engineering concern, there should be a medium sized laboratory for these such kind of things. Okay, then we'll move towards the another point, that is the large size laboratory. So again, we'll think about the basic facilities available, that is for the large size laboratory. So first thing, or first basic facility for the large size laboratory, that is one or more HV test halls. Means every equipment or every apparatus that has to be tested under a high voltage. So for that purpose, there should be one or more than one hall should be there, separate hall. Then second, that is another for the corona as well as pollution test chambers. Means the in that chamber only corona test, only radio interference test, only atmospheric pollution test has to be done. Third facility, that should be the outdoor test area fan. Means whatever be the large size equipments like a transmission like lines, like a towers, or the all other the equipments that has to be carried out into the outdoor test area. Then controlled atmospheric test rooms, or we can say chambers. So in such cases again, whatever be the atmospheric test like a pollution, like a weather conditions, like a rain, like a dry, like a fog, in that cases it should be have a controlled chamber, right? Then computer facilities, conferences hall, library with a good office facility. So means there should be now as a PLC SCADA is there. So in a high voltage, again PLC SCADA is taking playing a very important role. So there should be a computer facilities for the these programmings and all the things. Then conferences hall for the demonstration of these large size laboratories, or we can say whatever the test can be conducted, that should be studied, that should be done research. So for that purpose, then provision for overnight test and stay. Means what? Means in a large size laboratories, there should be a access of this laboratory for the 24/7. Okay, so people should stay there, people should do research on that, and people should take a test overnight. So that is again provision should be in this large size laboratories. So such kind of building and equipments that should including the workshop, including the handling equipments like a crane, like a ladders, air conditioners, air cushion platforms. So all these large control and the facilities which are up to kVA, or we can say which is beyond the kVA, which is up to mega, we can say megavolt ampere MVA. So in such cases, whatever be the director or the manager that are should be from the few group leaders, like I told you, Reliance, Adani, all such kind of few group leaders should be involved in such cases, and they should develop and design the large size laboratories. So there should be a research, testing, measurements, as well as electronic and computer facilities should be available. And in addition that, whatever be the supporting faculties should be there. They should be a testing engineers, they should be a technicians, qualified librarians, as well as such kind of semi-skilled or skilled worksmen will be there. So such kind of laboratories costing will be around several millions of the rupees. So that is the important thing, that investment for these kind of laboratories very high. So this is the major concern about these kind of laboratories. Okay, so cost is not a matter every time, so we'll just thinking about these laboratories which are giving a very good, we can say very good services for the live industry, services to the personal people. So this is all about the classification of these high voltage laboratories. So if you have any questions, please let me know. Any question, any doubt? Do you have any question? My question is very specific. Do you have any questions? Please let me know. Okay, for a minute, I'll just take you to the high voltage simulator. Okay, means you will understand within 5 minutes. We will just understand that one. Okay, please let me know whether my screen is visible to you or not. Is it visible, one and all?
Yes, sir.
Okay, thank you. So see, this is the virtual high voltage laboratory. Okay, so in such cases, I'll show you the whatever be the list of experiments are there. So this is the impulse voltage generator. Okay, so I hope that impulse voltage generator, whatever be it is here, that we will understand first. So see, after that we'll go for the current generator. Okay, so we'll understand whatever be the impulse voltage generator. So we had studied that theoretical part, and again here we can understand in the field of electrical engineering, whatever be the high voltage AC as well as high voltage DCs are there that are used for the several applications. So in such applications, for example, we can say electron microscope is there or X-ray units is there that required very high DC voltages. So it should be around 100 kV or more than that. Then again we can say electrostatic precipitors, particles accelerators, or we can say in a nuclear physics that kind of equipments are used which require very high or extra high transmission voltage. Okay, so in such cases we will understand whatever be the different types of the voltages are there, that is nothing but what, that should be a high voltage DC, then high voltage AC of power frequency, then high AC voltage of high frequency, then high transient or impulse voltage and transient voltage. So such kind of voltages will be there. So simple, whatever be the theory part for that, that is here in front of you, and already we had covered this part. So in such cases, whatever be a transient over voltages due to the lightning as well as switching action that causing a sudden steep in a voltage, so that may affect on the transmission lines or other electrical power apparatus. So whenever we are doing in experimental investigation, in that cases around 0.5 to the 10 microseconds, or the decay time is around 50%. So in such cases we can say that should be a 30 to 20 to 100 microseconds. So already we know this equation, that v naught, v is equal to v naught exponential minus 80 minus e raised to minus bt. So that is the perfectly formula for this, whatever be the double exponential waves is generating, for that this formula is used. So already we had seen this figure, right? This figure already we had gone through, and here you can see the CG means generator capacitance, VG means charging voltage. So these all are given here, and the basic introduction of every point is given to you. Okay, then we'll go further for this experiment, whatever be the objective was this, for understand or for measurement for the spark over and discharge voltage of a various test object. Then HV testing engineers are also the group of people who benefits apart from the academic and industrial personnel. Then to study the behavior of output impulse voltage pulse, when by varying different circuit parameters like a front end till resistors and the inductors that are as per the Indian electricity charge, whatever be the considerations are there. Then all these concepts, that IVG short form for this impulse voltage generator is IVG. So let us go for the simulator, and I'll just keep you procedure here. So first here, when the page is loaded, use will be presented with the 3D simulator representation of IVG on the right frame. So here you can see this is the impulse voltage generator, so IVG. So here you can see this is the 3D wave. Okay, so you can simply grab it and you can see how this can be changed here and there. So this is a 3D. Okay, this is a 3D. Okay, then what is the another instruction? Mouse hover on electric equivalent circuit to see the equivalent circuit of the simulator module. So if suppose I'll take my mouse on this equivalent circuit, here you will get the equivalent circuit diagram. So here you can see the equivalent circuit, like AC supply is given, right? So that electric AC supply is given. Then again, here you can see the rectifier circuit. Okay, here you can see the rectifier circuit. Then there is a ground switch, there is RS is a charging register. Then here is again whatever be the yellow registers are there, that is nothing but what, that is a charging registers. Then CG, there are 6 CGs. That CG means what, that means whatever be the generator capacitance are there, this is the CG. Then yes is nothing but what, there is a spark gap and spark gap. Again there is a ground switch, this RT RF. RT stands for the tail register, RF stands for the whatever be the front register. Then see R1 stands for the whatever be the damping register, that is used for the potential divider circuit. Okay, then this C1 stands for the high voltage capacitor, that is used for the voltage divider. Then here is RP is nothing but what, that is the terminal register of the voltage divider circuit. Then again this W means what, it is a measuring cable. Okay, then oscilloscope is there, that you can see P1 is oscilloscope, P2 is a voltmeter, and there is again biggest spark gap. So this is all the equivalent circuit diagram. So if you will go to here, then you can see all these diagram. You can see that whatever the supply is given, rectifier is there. So this 1 2 3, so that you can see 1 2 3 here. Okay, you can see here only 1 2 3, that is the spark gaps. Again there is a spark gap. Okay, so all that things are 3D. Okay, then what is the another step, another process? Mouse over on instructions to how to perform, then input parameters like naming charging voltage, ground capacitance, tail capacitance, front inductance, load inductance, front resistance. That should be the default values on the frame. Here you can see there is a default values. There is a 10 kV, zero point 0.6, all these value has been given default values. Okay, okay, then the user can conduct the experiment with the default values. However, the parameters can also be changed and the experiment performed. Means what? Whatever be the values are there, that you can change simply. Here you can write 15. Okay, means value you can change easily. Okay, so whatever be the values are there that are not confirmed, that are default values, so you can check that one also. Drag your mouse to see the impulse voltage test generator testing apparatus in details. You can also zoom in it by scrolling your mouse for the detailed study of IVG. Means, see, if I'll just like that way, see, you can see simply like that way. You can simply say check how it can be seen. Okay, so it is very simple in front of you, that you can easily understand how this is looks like. Okay, so I am just hovering that here and there. Okay, so you will easily understand how it looks like. Okay, so now you will go for the further instruction. After completing detailed study of IVG, set the value of voltage, spare gap, and click on to the start experiment. So now we'll go for the experiment. I'll just minimize that. Okay, now you see here. First thing, I'll just keep all the values as it is. Okay, so here what I will do, I will just click on the start experiment. So now whenever I had done I had clicked on the start experiment, then there is a second switch is enabled, that is open ground switch. So here you can see. Okay, so you can see here that switch has been done. Okay, this switch. Okay, let me show you once again that switch. Okay, here in this corner you have to in this circle you have to check. Okay, I'll click on restart. He see start experiment, then open ground switch. See, this switch is here again. Then I'll click on charge capacitor. So now whenever I am clicking on charge capacitor, you will see here in corner, you will see that capacitor are charging. Okay, so now capacitors are charged. Okay, that capacitors are charged. Now what I will do, I will click on trigger generator. Means my impulse voltage generator I am going to trigger, and now see what will happen. I click on trigger. Now you can see this spark gap is coming to cross over that, and you will get this waveform. You will get this waveform. See, this is the impulse voltage generator. Means for a particular instant, that is coming to here. Means voltage is 10 kV, all the values are there. So here you can see what, how much peak voltage that has achieved. That is around 27.56. And how much second? In 0.5 microseconds. And whatever be the tail time means what, in from this level to this level it has taken around 50 microseconds. So here, did you get the standard waveform for these values? You can click yes, and you click on save graph. Okay, so this graph is downloaded here. Then here you can click, so you will get the graph. Now what I will do, I'll click on the restart, and I'll just click on here. Whatever be the spare gap is there, that I will change to 10. Okay, that I'll change to 10. Open ground switch, so this switch is open. Then I'll charge the capacitors. So once this capacitor are charged, then I'll click on the trigger. Now my spare gap is maximum, spare gap is increased. So now that moment you can see my spare gap is increased. So what is my value for the peak voltages? Means you can understand, whenever my spark whatever the spare gap is there, if I increase the spare gap, my magnitude is increasing. Now again I'll show you. I'll do that one is to, I will just reduce it to the 5. Okay, now you can check here, For the 10, this is a 35. For the 5 centimeter, I'll click on the restart. Now see here, here this switch is C. Now here you can see that switch is a closed. Now once I'll click on open, so see white that white switch will get to this side. Okay, so click I'm clicking on it. You just observe in this uh, circle. Okay, so once I'll click on this open ground switch, now you can see that switch is going to open. Now I'll click to the charge capacitor. You should see on the left top corner. Okay, so as we had seen that we have charged the capacitor. Now clicking on the trigger, now you can see there is a spare gaps. So in this spare gap, how now there is a 5 centimeter spare gap, and now I click on trigger. So see how this is our triggering, and now these are triggered, and you can see the value of these whatever be the. So like that way we can perform the figure, and you can see by zooming that one. So you will see there is a microseconds. Okay, and there is a upside. You can see this is a voltage versus time curve. Okay, so this is for the time impulse voltage generator. You can perform that into your mobile also. So all these operation procedures has been given. So by next lectures or next few lectures we'll go for the another also, that rectangular pulse voltage doubler. That voltage doubler I think already we had seen. Then impulse of current generator, so how it is going to test power frequency AC test source, that is also here. So it is under working progress. So this is again impulse current generator. So now simply I will show how it looks like. So if I click on this open ground switch, so switches are open, charging a capacitor, same procedure is again there. But now you can see here is a red colors capacitors. Now it has been charged to the green color, and clicking on the trigger. So here is triggering going on, and you can see how current is going to increase. See, this is the this is the figure what we need. That is the figure. So here you can see how this current is taking place. So like that way it has gone to the 2.49 means 2.5 around in a 1 microsecond. So like that way we will understand this impulse current generator in the next lecture. Okay, so for now I hope it is clear to everyone. So let me take an attendance. Okay, fine. So now you can leave the class and can go for another class.